This is Math 113, 23rd trimestral, and our lessons for today is all about continuous function. So, what is a continuous function? In section 1.2, we saw a few nice functions whose limit as x approaches a. Okay, simply involve substituting a into the function. The limit of the function of x as x approaches to a is equal to function of a. Function whose limits have these substitution properties are called continuous functions. So ito yung magiging formula po natin sa continuous function. The limit of the function of x as x approaches the a should be equal to the function of a. And they have a number of other useful properties and are very common in applications. We will examine what it means graphically for a function to be continuous or not continuous. So some properties of continuous functions will be given, and we will look at a few applications of these properties, including way to solve horrible equations such as sine x equal to 2x plus 1 all over x minus 2. Okay? So last week, if you still don't remember, our lessons is all about the uh, properties of limit. Okay, we discussed the different method in finding the limits of the functions. So we have the algebra method, we have the table method, and we have the uh, graph method. So by this time, we're going to apply what we have learned in graph method in finding the limits of the functions. Okay, so definition and meaning of the continuous. So definition of continuous at a point, a function f is a continuous at x is equal to a if and only if the limit of the function of x as x approaches to a is equal to the function of a. So ito dapat ang ma-justify natin that your left equation is the same as your right equation. Okay? So this now our basis. The graph in figure 1 illustrates some of the different ways a function can behave at and near a point, okay? And table 1 contains some numerical information about the function and its behavior. Based on the information in table 1, we can conclude that f is continuous at 1 since the limit of the function of x as x approaches to 1 is equal to 2 is the same as the function of 1. We can also conclude from the information in the table that f is not continuous at 2 or 3 or 4 because the limit of the function of x as x approaches to 2 is not equal to the function of 2. The limit of the function of x as x approaches 3 is not equal to the function of 3, and the limit of the function of x as x approaches to 4 is not equal to the function of 4. Okay? So how are we going to check that? So we have here the figure 1 and table 1. It says that based on the information in the table 1, we can conclude that f is continuous at 1. Since the limit of the function of x as x approaches to 1 is equal to 2 is the same as the function of 1. Okay? So, okay? So from our graph method, pag naalala mo, how do you are going to find a limit? So ang gagawin po natin, as x approaches to 1, okay, project it upward, then we have your limit which is equivalent to 2. So ganun po yung pagkuha ng limit using your graph method. Okay? So in your table 1, we have your 3 columns. Your A, we have 1, 2, 3, and 4. Your A, these are the values of your x coordinates, no? So we have your second column, the function of a, and the third column, the limit of the function of x as x approaches to a, ito na siya. So first, the function of a, so if you're going to have a is equal to 1, okay, project it upward, then project it to the left, the answer is 2. So, may sagot tayong 2 dito. And also, in your third column, the limit of the function of x as x approaches to 2, approaches to a, your a is equal to 1 is equivalent to 2. The limit of the function of x as x approaches to 1, okay, kung saan po yung graph po natin, yung functions po natin, tumama po siya. Then project it to the left, the answer is 2. Kaya sabi ni dito, based on the information in the table, we can conclude that f is continuous at 1. Bakit continuous at 1? The limit of the function of x as x approaches to a is equal to 2. Ito na yon. And also the function of a, which is equivalent to 1, the answer is 2. So these two are equal. So we can say that at a, our function is continuous. Okay? So next we have number 2. Function of a is equal to 1. So ito yung 2 natin. Oops, dito tumama. Meron tayong tuldok dito. Solid na circle. Project it to the left. Our answer is 1. Yun po siya. Okay? So, samantalang dun sa isa, the limit of the function of x as x approaches to a, our a is equal to 2. Project it upward. Project it to the left. The answer is 2. Okay? So, doon sa function of a po natin, pag tinitingnan po natin, ang tinutumbok niya yung mga solid na circle. Okay? Pero doon sa functions po natin, doon sa third column, doon sa limit po natin, kung saan po tatama yung ano natin, x natin doon sa function. Kaya dito siya tumama. Kaya ang sagot niya ay 2. Sa function of a natin, dito siya tumama dahil nandito yung solid circle, ito na siya. Okay? So, during your graph method, meron po tayong tawag dito. Hindi ko alam kung naka-attend ka doon, no? So, ang tawag po dito, pag meron kayong point na hindi tumama doon sa graph po natin o sa functions po natin, ang tawag po dito is irrelevant limit. Okay? So, yung tawag po naman dito, this particular D, undefined limit. Kasi meron siyang circle. We call this one undefined. Okay? Next, we have number 3, no? Check natin yung A is equal to 3. As A approaches 3, okay? Okay, dahil function siyang, kukunin natin yung solid na circle. Nandito siya. Our answer is 2. Okay? Pero dito, the limit of the function of x as x approaches to a, our answer is does not exist. Bakit does not exist? Dahil meron tayong undefined limit. Ito yung undefined limit po natin. At the same time, na-break po yung functions po natin. Hindi siya dumugtong dito. May cut po siya. So, hindi natin alam kung asan yung limit natin. Pwede siya dito or pwede siya dito. Kaya tinawag nila does not exist. Or, we call this one, at x is equal to 3, there is no limit. Dahil di natin alam, pwedeng 2, pwedeng 1. Kaya, does not exist po siya. So, pag titingnan po natin, hindi rin po siya equal yung column 2 sa column 3. Kaya hindi rin siya masabing continuous functions. So, we have number 4. Okay? As A approaches to 4, we have your D undefined. Okay? Ito yung undefined po natin. Okay? Dahil wala po siya, no? Wala siyang tulok dito. As A, pag gagamitin naman natin ito, as x approaches to 4, the answer is 2. 2 na po siya. Okay? So, pag titingnan po natin, starting A is equal to 2, 3, 4, table 2, column 2 and column 3 are not equal. So, which means these functions at 2, 3, 4 are discontinuous functions. Okay? So, to make it summarize, ito na siya, no? Informally, a function is continuous at a point if the graph of the function is connected there. So, the word there is connected. Kapag connected siya, yung ganitong symbol. Okay? A function is not continuous at a point if its graph has a hole or break at that point. So, meron tayong hole dito. Meron tayong break, meron tayong hole. Kaya hindi siya continuous functions. So, yun po yung pinaka-summary po natin. Okay? So, by looking at the graph alone, we can say if the function is continuous. Okay? Dapat connected siya. There is no hole. There is no break of the function. Okay? So, next you have your example number 1. If the function of x equal to x plus 1, if x is less than 1, 2 if x is greater than 1 or less than 2, 1 all over x minus 3 if x is greater than 2. Okay? So dito, we could answer this question by examining the graph of function of x, but let's try there without the graph at a is equal to 1. So the function of 1 is equal to 2. Ito na siya, no? Function of 1 is equal to 2, and the left and the right limits are equal. So the function of x, limit x plus 1 as x approaches to 1 is equal to 2. So ang limit, the function of x as x approaches to 1 is equal to limit 2 as x approaches to 1 is equal to 2. So ito na po siya yung sinasabi niya. As x approaches to 1, the answer is 2. So f is continuous at 1. Okay? Continuous at 1 siya. Then ang sagot nila, function of 1 is equal to 2. Limit of x approaches to 1, the answer is 2. Okay? At a is equal to 2, the function of 2 is equal to 2, but the left and the right limits are not equal. Okay? Function of 2, they are not equal. Sabi dito, the limit of function of x as x approaches to 2 is equal to limit 2 as x approaches to 2 is equal to 2. Ito na yun, no? Okay? And limit the function of x as x approaches to 2 is equal to limit 1 all over x minus 3 as x approaches to 2 is equal to negative 1. So f fails condition in second statement and is not continuous at 2. F is continuous from the left at 2 but not from the right. Okay? So ito yung sinabi niya. So f is continuous at from the left. Continuous siya dito. Not from the right. So yun po siya. Okay? And also at a is equal to 3, the function of 3 is equal to 1 all over 0. So nakuha yung 0, 3 minus 3, the answer is 0, which is undefined. So f is not continuous at 3 because it fails the given condition on the first statement. Okay? So yun po yung ibig sabihin po natin, by means of the graph alone, we can say where the point is continuous or not. Okay? So we have your, for 3 minutes siguro, kaya natin isolve to, no? It's your turn, no? At which points the function in figure 14 discontinuous. So ito yung figure 14 natin. Number 2, at which points the function in figure 15 is also discontinuous. Okay? Kaya natin isolve by looking at the graph. So for 5 minutes, paki-solve po yun by looking at all those points na hindi discontinuous sa figure 14 at saka figure 15. Okay? So by looking at your figure 14, no? Okay, no? So 1 and 4. Okay? So tama yung sagot mo, no? Pero may isang kulang, no? Doon sa 1, hindi siya continuous dahil siya ay undefined. May butas. Okay? Pagdating dito, okay pa rin. At 3, may cut po tayo dito. So discontinuous pa rin siya. Although may solid circle po siya dito, pero pag titingnan po natin, magmula sa 2, papuntang 3, siya ay nakat. May break po siya. Kaya discontinuous pa rin po siya dito. Pagdating sa 4, tama yung sagot mo, dahil ito undefined, pwede rin undefined din ito does not exist. Dahil meron kayong break, at the same time may undefined po dito. So yung limit po natin dito is does not exist. So at point 4, that is also discontinuous function. Okay? So kulang ka ng isa. In your figure 15 naman, tama yung sagot mo. There are only 2 points which are discontinuous function. Sa 0, dahil meron tayong undefined. Sa 2, tama rin, pero meron tayong undefined, dalawa, meron tayong isang irrelevant. So this one is no limit. So this is a discontinuous functions. Okay? So alam mo na siya.
Opo, sir.
Okay, ganoon lang po siya kadali, no? Sa graph alone, makikita po natin kung discontinuous or continuous functions po siya. Okay? So we have your example number 2, where is the function of x equal to x squared minus 2x continuous. At every point, by substitution theorem for polynomials, every polynomial is continuous everywhere. Ibig sabihin po nito, if you're going to substitute any values of a, okay, dito sa function na yan, and then you're going to plot that in your x and y axis, okay, makikita po natin na yung functions natin ay continuous if you're going to connect those points of intersection. Okay? So, yun po yung ibig sabihin po niya. Okay? Any questions po dito?
Wala naman po, sir.
Okay. So, next we have your D, combinations of continuous functions. If the function of x and g sub x are continuous at a and k is any constant, then the elementary combinations of f and g, okay, k multiplied by f multiplied by x. So we have now the theorems on limit, no? Constant multiplied by the function. Next, we have your d addition. Function of x plus g sub x, function of x minus g sub x, subtraction, fx minus g sub x, we have the multiplication. And fx divided by g sub x, we have the division. Provided that your g sub a should not be equal to 0. So pag titingnan po natin, kaya tinawag nilang combinations dahil kanina nag-isa lang yung functions pa natin, f of x. Pero dito ngayon, meron tayong g of x. So, ibig sabihin niya, pag ito naging 0, hindi siya pwedeng sabihin na combination dahil nag-iisa lang siya. So, dapat ito ay hindi maging 0 para pag inad mo itong dalawa na ito, pinag-combine mo, kaya tinawag nilang combinations of continuous functions. So the continuity of function is defined in terms of limits. And all of these results about simple combinations of continuous functions follow from the results about simple combinations of limits in the mean limit theorem. Our hypothesis is that f and g are both continuous at a, so we can assume that the limit the function of x as x approaches to a is equal to f of a, the function of a. So, dapat itong dalawa ay equal. Tulad yung ginawa natin doon sa figure 1a po natin. Figure 1 is table 1. Dapat pareho sila para maging continuous. And also, limit g is a function of x as x approaches to a is equal to g sub a. So, dapat itong dalawa rin, silang dalawa ay pareho yung value para maging continuous sila. Pag ito continuous, continuous dyan, then if we're going to continue, combine that one, then we're going to have the combinations of continuous functions. Okay? So, and then use the appropriate part of the mean limit theorem. Okay? So, this is your mean limit theorem. For example, the limit of function of x plus g sub x as x approaches to a. So, ang gagawin po natin, i-distribute natin ito sa bawat function using the addition properties of limit. Okay, so nangyari, limit the function of s as x approaches to a plus the limit of g is a function of x as x approaches to a. To make the functions continuous, dapat ito will be the same as ito, f of a. Ito yun, no? Para maging continuous siya. And also, this one, using this principle, dapat pareho lang siya sa g is a function of a. And if we're going to add that one, so f plus g is continuous at a. Okay? So how we're going to define that one? Sabi dito, for the function of x is equal to x squared minus x minus 6. And g sub x is equal to x squared minus 2x minus 3. Evaluate the following limits. Okay? So this is our example known sa functions of limits, no? You still remember how we're going to solve this one. So the limit the function of x as x approaches to 1 plus g is limit quantity f of x plus g sub x as x approaches to 1. Okay? So by using the algebra method, do you have any idea? Ito yung
Wait
kanina
lang,
siya
sir.
sabing continuous function, no? Itong balik natin sa ano natin. Yung example 2 natin, ito yung solution niya, no? Yung at every point by substitution theorem for polynomials, every polynomial is a continuous everywhere. Ito siya, no? The function of x equal to x squared minus 2x. If we're going to substitute as x approaches to 1, our answer is 1. So
1.
3 times 1 is squared minus 2 multiplied by 1. So 3 minus 2, the answer is 1.
1.
Okay? So next, as x approaches to 2, so substitute natin siya dito. Okay? 2 is squared is 4 by 3 is 12 minus 2 by 2 is 4. So 12 minus 4, we have 8. As x approaches to 3, 3 squared is 9 by 3, 27. 2 times 3, we have 6. So 27 minus 6, we have 21. Next, as x approaches to 4, 4 squared is 16 by 3 is 48. 2 by 4 is 8. So 48 minus 8, we have 40. So if we're going to plot that one in your x and y coordinates, ito na yung limit mo natin. As x approaches to 1, the answer is 1. Ito yan. As x approaches to 2, our answer is 8. Next, as x approaches to 3, our answer is 21. For the last one, as x approaches to 4, our answer is 40. So, ang gagawin po natin ngayon, i-connect natin po yung mga lines na yan. So, if we're going to look on the figure, we're going to have now a continuous functions dahil tuloy-tuloy po sila. Kasi meron siyang the sure function of 3 is equal to 21, function of 2 is equal to 8, function of 1 is equal to 1. Because the limit of the function of x as x approaches to a is the same as the function of a. Pareho lang sila. Kaya tinawag nilang continuous. Okay? So next, ito yung ano yung sagot mo kanina? 6 at saka 3, no? 6 at saka 3 yung sagot mo kanina.
Opo, sir. Opo.
Okay, check natin, no? So, function of x is equal to x squared minus x minus 6 as x approaches to 1. So, if we're going to substitute that 1 squared is 1. Minus 1 is 0. So, 1 minus 1 is 0 minus 6. The answer is negative 6. Sa g of x po naman natin, as x approaches to 1, so we have x squared minus 2x minus 3. 1 squared is 1. Minus 2 times 1 is 2. 1 minus 2 is negative 1. Minus 3, the answer is negative 4. So ito yung f of x natin. Ito yung g of x. And if we're going to add that one, f of x as x approaches to 1 plus g of x as x approaches to 1 is equal to negative 6 plus negative 40. Negative 4, the answer is negative 10.
Negative 10.
Okay? If we're going to plot that one in your x and y axis, our x, this your x, this your y. So we're going to have in the fourth quadrant. Back in the fourth quadrant, yung a natin is positive, which is equivalent to 1. Tapos yung y natin is negative po sila. Okay? If we're going to have that one, as a approaches to 1, yung f of x natin is negative 4. Okay? As a approaches to 1, yung g of x natin is negative 6. And if we're going to add these 2 points, okay, f of x plus g of x, our answer is negative 10. Okay? So, pag i-connect mo yan, then magkakaroon tayo ng continuous functions. Dahil wala tayong broken functions or meron tayong whole na functions. Wala. Dahil as a is equal to 1, f of x is negative 4. As a approaches to 1, g of x is negative 6. As a is equal to 1, f of x plus g of x is equal to negative 10. So yun po yung sinasabi ng combinations of continuous functions. Pag in-add mo itong dalawa, okay, they're still continuous functions. Okay? So ito na siya, no? So, ipoprove po natin if f and g are continuous at A, then kf is an f minus g, itong dalawa ang ipoprove po natin, are continuous at A if k is a constant. So to prove that kf is continuous at A, we need to prove that kf satisfies the definitions of continuity at a is equal to the limit of key fx as x approaches to a, dapat equal sila sa key fa. So, k multiplied by function of a. Okay? So, ito yung formula natin sa continuous functions. Dapat mag-satisfy sila dun sa equation na yan. So, using results about limits, we know the limit of k f x as x approaches to a, where k is constant. Okay, ilalabas mo natin siya. So, using the multiplication property. Tapos, limit f of x as x approaches to a. So, yung k, nandun pa rin dahil constant siya. So, dapat itong dalawa, para maging continuous siya, limit fx as x approaches to a, dapat is equal to the function of a para maging continuous functions po siya. Sabi dito, since f is assumed to be continuous at a, so key f is continuous at a. So yun po yung ginastify po natin. Basta itong dalawa, fa saka ito ay pareho to make our function continuous. Next, to prove that f minus g is continuous at a, we need to prove that f minus g satisfy the definition of continuity at a is equal to the limit of quantity f of x minus g sub x as x approaches to a. So we're going to use the distributive property. So dapat ito pareho lang siya sa function of a, tapos ito pareho lang siya sa g sub a using the mean limit theorem formula. So again, using information about limits, okay, so distribute na natin. Okay, so naging limit of f x as x approaches to a, ito siya, then minus limit g sub x as x approaches to a. Okay, so to make it continuous, dapat ito mas equal to fa, tapos ito dapat mag-equal to g sub a para maging continuous function sila. So since f and g are both continuous at a, so f minus g is continuous at a. So yun po lagi i-justify natin na itong value using your limit, dapat pareho lang siya doon sa functions. Okay? Para maging continuous sila. Okay? Sabi dito, why do we care whether a function is continuous? So there are several reasons for us to examine continuous functions and their properties. Most of the applications in engineering, the sciences, and businesses are continuous, are modeled by continuous functions or by pieces of continuous functions. Also, continuous functions have a number of useful properties which are not necessarily true if the function is not continuous. So tama po yun, no? Not necessarily true if the function is not continuous. Ibig sabihin, may problema. If a result is true of all continuous functions and we have a continuous function, then the result is true for our function. This can save us from having to show one by one that each result is true for each particular functions we use. Some of these properties are given in the rest of this section. Okay? So also differential calculus has been called the study of continuous chains. And many of the results of the calculus are guaranteed to be true only for continuous functions. If you look ahead into chapters 2 and 3, you will see many of the theorems of the form if f is continuous, then you can provide additional hypothesis and you can form a conclusion. So yun po yung ibig sabihin niya. So how we're going to apply that one? Okay? So ito yung common applications niya, no? So halimbawa in our figure 14, no? So halimbawa nasa sales po tayo sa isang kumpanya and you're going to represent your output sa sales, okay? So tapos ang ginawa mo, ganitong figure siya, how you're going to discuss that with your big boss, okay? Let's say for example, yung x coordinates natin represents your month, no? November, December, January, February, March, April, May, no? Tapos sabihin mo, this is now the graphical representation of our sales from November to May, okay? So how are we going to discuss that one? Sabi mo, At November, we have a continuous sales, okay, until December, okay. By January, there's a problem. Ibig sabihin, there is a undefined problem. So, may problema po tayo dito because there is undefined. Bakit siya bumagsak? Yung sales natin, hindi po siya naging continuous. So, ito yung main concern po natin for the month of January. So, dapat alamin po natin kung ano yung problema. Okay? Pagdating ng February, okay naman yung sales po natin. From February going
Opo.
to March, parang okay naman siya. Pero of uh, when March comes, ibig sabihin nakat po yung sales po natin. Biglang bumagsak. So, ibig sabihin may problema sa March po natin na sales. Okay? From March to April, okay naman. After April, going to May, ibig sabihin may problem. Our sale is not continuous because it has another flow of sales po natin. So, yun po yung common applications po natin. Sabi kanina, pag ang ano natin is continuous lahat, wala tayong problema, everything is true, and RF functions is true, all is continuous functions. Okay?